Okay, so welcome back. And so now what we're going to do is we're going to look at this harmonic series more analytically. Okay, so I've written out several of the partial sums, 1 through 8. Okay, and the reason I did that is so we can see a pattern more easily. So notice that for this one here, so we'll look at s sub 1 is equal to 1, and then s sub 2 is equal to 1 plus a half, okay? And then s sub 3 is equal to 1 plus a half plus a third, okay? And then now let's look at this one here, s sub 4. We have 1 plus a half plus a third plus a fourth, but notice that this is greater than, let me write it over here. So this is, let me do this. So this is greater than 1/4 plus a fourth, which equals 2/4, which equals a half, right? Okay. So now let's go on. So s sub 5 is equal to this. And then s sub 6, you add on 1/6. And then s sub 7, you add on 1/7. And then when you get to s sub 8, you add on an eighth. But now notice something. So let's look at these two again. But now let's look at these four. So if we look at these four here, then what do we get? Well, we know that if we make all of these 1/8, right? 1/5 is definitely bigger than an eighth, 1/6 is bigger than an eighth, and 1/7 is bigger than an eighth. So we can say that this sum is bigger than 1/8 plus 1/8 plus 1/8 plus 1/8, which equals 4/8, which is equal to 1/2. Okay, so now, what does that tell us? Okay, so this here, we can rewrite, this is bigger than what? 1 plus a half plus a half. Right? Okay, this here equals 1 plus a half. Times 1. This one here could be equal to 1 plus 1/2 times 0. This here is equal to 1 plus a half times 3. Or no, I'm sorry, 2. Getting ahead of myself. 2. So now here, we got that. And then down here, then we have this is bigger than, right? 1 plus what? It'll be 1, 2, 3. So it'll be 1/2 times 3. And so now we see this pattern with these partial sums at S sub 1, S sub 6, S sub 4, S sub 8. And now if we continue this pattern, and again notice that this pattern continues for each index as a how do I put this? As the index doubles, if you will. So it doubles from 1 to 2, 2 to 4, 4 to 8, and so the next term in the pattern will go to 16 and so on. Okay, so how do we write this? So this is going to be equal to S sub j. Oh no. No. S sub 2 to the jth power. Okay? So the index is of the form, so in other words, k, S sub k, where k is equal to 2 to some power of j. Okay? And so now we're representing the partial sums as follows. So S sub j squared is going to be what? It's going to be greater than what? So this was 0, right? So j to 0 gives us k equals 1. Good. If j is 1, we get 2, right? If j is 3, we get 8. Okay? So that means our formula on the right-hand side is going to be this. It's going to be 1 plus 1/2 times j. Okay, now, this here is we're always adding a half. So again, as j goes to infinity, this side here is unbounded. It goes off to infinity. And since the sequence of partial sums is always greater than the sequence, remember, so this sequence is unbounded. This sequence of partial sums is larger than this sequence. So if this is unbounded, this sequence is also unbounded, and therefore the harmonic series diverges. Okay, that's it. So next we'll introduce a theorem for the algebraic properties of convergent series. Very similar to what we talked about when we talked about properties of convergent sequences. See you then.